Arrange the following radicals in increasing order. Here we first have to estimate decimal values for each of the radicals. We do this based on proximity of the radicand to perfect squares, cubes, powers of 4, or powers of 5. First of all, for the square root of 10, we know that the square root of 9 equals 3, and the square root of 16 equals 4. The square root of 10 then must be in between 3 and 4, but closer to 3, since 10 is closer to 9. A decent estimate would be about 3.2. For the cube root of 70, the cube root of 64 equals 4, and the cube root of 125 equals 5. This means that the cube root of 70 must be in between 4 and 5, a lot closer to 4. 4.1 would be a good estimate. For the fourth root of 200, the fourth root of 81 equals 3. The fourth root of 256 is equal to 4. The fourth root of 200 then is in between 3 and 4, but closer to 4. A good estimate here, about 3.8. Finally, the fifth root of 225. The fifth root of 32 equals 2, and the fifth root of 243 equals 3. The fifth root of 225 then is between 2 and 3, much closer, however, to 3. A good estimate here, about 2.9. We can then look at the decimal numbers and order them in increasing order. Note that 2.9 is the smallest, then 3.2, 3.8, and 4.1. This corresponds to the fifth root of 225 being the smallest, then the square root of 10, then the fourth root of 200, and the biggest is the cube root of 70.